Right, some few examples on logarithms. In this case, I'm not going to take any base. I'm just going to concentrate on ln, the natural base. And we assume that whatever property you apply concerning ln applies to any other base. That's right. Good. So now we've got an expression here which says ln of x minus b ln of z plus a ln of y. The order of exercise says express the following as a single logarithm. Then we've got to think about logarithm of products, logarithm of quotient, other properties of ln. Now, so before we can express this thing as a single logarithm, there's something you must do. There's one property you must apply first. Which one? Sorry? The power one, is it? So now we have got to use it there and there. What does the logarithm power saying? It says if you've got p ln of n, this is same thing as ln of n power p, isn't it? So I'm writing it there, and what I want to highlight that every time you make a move, you must, even if you don't write it like I'm writing it there, because I'm teaching myself, you should have in mind which property you are using in order to move, isn't it? So you can say now this is equals to ln of x minus ln of z to the power b plus ln of y to the power a. Altogether. Now, which one do you think next property are going to apply now? The addition one, is it? Okay. So, then we apply addition. Maybe first of all, let's organize this thing this way. Say plus ln y to the power a for people to see it more like suggestive. Then this expression can be, this term, this part of the expression can be crushed into one logarithm, is it? What should I write there? What should I write? Talk, guys, talk. Who wants to talk? Let's see. Can you speak up? Yes, speak up. Ln of x, ln of x times y to the power a minus our minus our ln of z to the power b. And what we did there, we're using this ln of m plus ln of n equals to ln n times n, m. How do it? Then we come here. We like have got subtraction there, isn't it? So we know, once you see that, we know that this involves division, isn't it? We must know which one is the numerator, which one is the denominator, isn't it? Then again, this you can mirror it to the rules of exponent. Where did you use the subtraction? Which power was subtracting which one, isn't it? Because logarithms, basically, those are the powers. When I talk about log of 8, I'm talking log of 8 base 2. I'm talking about the power to which 2 is elevated to get 8. So this is not very far from that. So how do I write this now? Ln of xy to the power a over z to the power b. Then that's that. Altogether, I hope you can think also that if you are given this thing, you must imagine how you could start it to reverse it back to the beginning there, because these processes are supposed to be reversible, isn't it? Okay, that's that. Any question there? Any question? No question. Then you say, evaluate the following. Evaluate the following. Maybe let's clear that. you are required to evaluate the following. This is just a practice of what you've learned. Exponentials, logarithm. At once, you must try to understand that. Evaluate the following without using a calculator. You've got here log base 3 of 80, log of 80 base 3 minus log base 3 of 4. You need to use the properties, only the properties, to evaluate this kind of expression without using a calculator. What do you think you must do? Simplify the bracket. So what are you going to write? Come again? 3 to the power log 80 over 4. Okay. Base 3. Okay. Then, what is 8 divided by 4? 20. 8 divided by 4? 20. Okay. Then log. Then what do you do next? Can you go further, simplify without using a calculator? 20 is not a power of 3, is it? Yes or no? It's not. It's not. So what can we do there? Can we simplify that further, or is it impossible to simplify? Can you simplify it further? I don't see how you can simplify it further without a calculator there. What can you do it without a calculator? Huh? Sorry? Think about it and see whether you can simplify it to the simplest form without using a calculator, without even using the expression log and further. Right. Now, I want to go to another, let's say an exponential equation here. It says solve for x, round your answer off to 4 decimal places when necessary. Solve for x and round off to 4 decimal places when necessary. But maybe let's start with this one. It says E, now it's equations. Maybe let me get rid of this first. This is an equation. It says solve. We've got E to the power 2x plus 3 minus 7 equals to 0. You've got to solve for x. Otherwise, at the end of the day, you must get x equals to something like to 4 decimal places. Now, what we're going to do here, I think when you're working with log and exponential, it's best to have one term on the left hand side, one term on the right hand side. One single term. Then you can maybe apply the properties of the log. What I'm going to do here, let's subtract or add both sides, 7. Add both sides 7. What I'm going to have here, I'm going to have E to the power 2x plus 3 equals to 7. As you can see there, I didn't do it like usual way of adding, but just indicating that we're adding 7 on both sides there. Now, the next thing, what can we do? We can apply ln now. Say ln E to the power 2x plus 3 equals to ln of 7. Already this is going to be a decimal number, isn't it? Okay. Then what you need to do now? Use that property. Then get 2x plus 3. Please be careful when you do this thing. You need brackets there. All together. Then what can we simplify there? Ln E, what is equal to? 1. So we've got now 2x plus 3 equals to ln 7. Now another comment there. When you're given a problem and you are supposed to give the answer to a certain number of decimal places, it's best to work with an expression like this until the end. When you've got x, then you can round it off. If I put a decimal number there and then continue this way with the decimal number, you make your answer big. Because remember, decimal numbers are kind of approximation. That's right. So once you introduce a decimal number, you have introduced an error also. So I'll prefer that you work throughout as it is. Then at the end, I'll tell you where to. Let's see what's going to happen here. Now we say, okay, you get 2x plus 3 minus 3 equals to ln 7 minus 3. Then we're going to end up with 2x equals to ln 7 minus 3. All together. Then after this, we can divide both sides by 2, isn't it? Then maybe let's write here and say, therefore, x is equal to ln 7 minus 3 over 2. Then evaluate here. Maybe get your answer. I'm not going to evaluate that. Use a calculator to evaluate that. Maybe you're going to get your answer. Maybe something like, maybe let's just say, comma, all together. He said give the answer to 4 decimal places, isn't it? I'll write this answer to at least 5 decimal places, this one. Then when I finally give my final answer, and say x equals to something, comma, 1, 2, 3, and say to 4, correct to 4 decimal places. Am I making myself clear there? Yeah. So please don't introduce decimals early if you've got the expression like this. Just try to introduce them right at the end, then you reduce the error in your answer. Right. Questions? Questions? I think we've got time for one example more before I can explain what this guy was asking about. Let me take this kind of an equation. So another example. We have got here ln of 5 minus 2x equals to minus 3. Do you remember what I said about the domain of logarithm function? Who can remember? What is the domain of logarithm function? The domain of logarithm function? Sorry? X must be greater than 0. Now it's the positive real number. Now, you see what's written here? It's written ln of 5 minus that. The assumption is that this value is positive, because if it wasn't, you can't use the brackets there. What I'm trying to call attention to, you'll find that in most mathematics books, you'll find ln written this way. Maybe you've already seen it. That will be written this way. To emphasize that that argument is only going to be considered when positive, because the absolute value, it's always outputting what? Positive numbers. But then when we write it this way, we can actually say we're writing it a bit carelessly, but I think in the back of our mind, we must understand that this must only take, this argument must always be positive. Now, when you've got that now, this is what we're going to do. This is what we're going to do. We need to have x as x equals to something. But x here is underlined. We need to call an inverse function which is going to undo the lim and give us the argument as an identity. Is it composing? So what do you do there? What do you do there? We write e to the power lim brackets 5 minus 2x equals to e to the power minus 3. Altogether. Then here, because this is an inverse of that, it's going to give us the argument. So we're going to have here 5 minus 2x equals to e to the power minus 3. Am I making myself clear there? Does everybody follow that? Sorry? Do you follow that? Okay. So now, again here, if you take the calculator and express second function of lim and say second function, you go to the key lim, but you expect second function. You expect second function. Else you on the calculator, the key for lim will be like this. E would be sitting somewhere there. So if I press second function and key here, it will give me, now it's going to calculate exponential base e of minus 3. And then give me a decimal number. Is it? So now, let's leave it like that for a while, and then say here, subtract 5 on both sides. Then what we're going to have, we are going to have minus 2x equals to e to the power minus 3 minus 5. Then next we will divide both sides by minus 2. Then you get x equals to e to the power minus 3 minus 5 divided by 2. Then you go to your calculator, minus 2, sorry, minus 2. Then you can go to your calculator and key in this, and then you are definitely going to get a decimal number with number of places there. Like I said, you must first of all, when you copy from the calculator, copy that number correct to 5 or 6 decimal places, isn't it? Altogether. Then you will later show here that therefore x is equals to, then you write 4 decimal places, comma, and then say 2 4 decimal places. Then you are given an answer. Altogether. Then you can see that you know how to calculate, you know how to run the numbers to a given decimal places. I think for today I'm going to stop there and say thank you for listening. I hope this helps you to start on your practice.